off by talking about the tangent ratio, which won't make sense at first. We're just going to learn a pattern, and then we'll see how to use it to solve missing sides and then missing angles of a triangle. So, tangent ratio. It's a trigonometric ratio, which we just call trig for short, so you don't have to say trigonometric every single time. We just say trig, is a ratio of lengths of two sides of a right triangle. The big thing is the trig ratios only work with right triangles. Remember when we learned the heartbeat and the bunny ear method, and I said it only works for the altitude of a right triangle? Guess how many people applied it to things that were not altitudes of right triangles? More than zero, way more than zero. So take it at face value that you have to have a right triangle to use a trig ratio. All right, so you have to have a right triangle to have trig ratio. And you do not use the right angle when working with trig ratios. That means you won't be plugging in 90 degrees. If you find yourself plugging in 90 degrees into your calculator, you did something wrong. All right, our tangent ratio says the tangent of an angle equals the opposite over adjacent. The way I kind of remember this, and we'll talk about this with other ones, is the word TOA. Tangent is opposite over adjacent. TOA. Because we're going to learn about sine and we'll learn about cosine on Monday. But right now, just think TOA when you think tangent. So tangent is TOA. That means side opposite over adjacent. Like I said, this might be a little confusing until we actually put numbers with it. This is the quick way to write it. Instead of writing tangent, we just write TAN. Tangent of an angle equals opposite over adjacent. And we'll see this on the other side. Opposite is always going to be the one that you can draw a straight line to. So if I'm looking at angle A, the opposite one is this one. In fact, the opposite one does not touch the angle at all. Our adjacent leg will be the one that's actually touching the angle. As you can see, angle A is made up of the hypotenuse and this leg. Does tangent say anything about the hypotenuse? No. You will not be using the hypotenuse at all today. We are only talking about legs. So when I talk about adjacent, I'm only talking about leg. I'm never talking about the hypotenuse. Adjacent is always a leg. If I mean hypotenuse, I will say hypotenuse. So if anytime I say adjacent, I'm talking about the adjacent leg, just to be clear. All right, then our first example says find tangent of B. Well, angle B is up here. So the opposite side is going to be way down here. It's going to be the side that doesn't touch angle B. Well, that's side B. Adjacent means either I'm talking about C or A. But like I said, adjacent always means leg, never means the hypotenuse. So I'm going to be talking about side A. Let's do that in green. So it's kind of like you draw a little curly arrow. So that's going to be side A. So it's going to be B over A. Tangent A is going to be similar, except what is the opposite of angle A? EJ. A is. Yep. So that makes our adjacent B, because I'm not talking about the hypotenuse. So tangent A equals A over B. Tangent B equals B over A. All right, let's do some numbers. So if we look to the right there, it says tangent of angle X. What would tangent of angle X equal with those numbers of the sides? Libby? 12 over 5. Yeah, perfect. The good thing about tangent is it doesn't use the hypotenuse. So in my head, I'm almost thinking that 13 disappears because I can't use it with tangent. All right, if tangent of X equals 12 over 5, what does tangent of Y equal? Songa? 5 over 12. That's just the ratio. That's just ratio. We'll figure out how we use that to actually find missing sides and angles in just a second. But before we do that, we have to know how to use our calculator. Because if I say tangent of 30 degrees, I'm guessing there's no one in here that just knows that off the top of their head. My pre-calc students would, but... Oh, you know it off the top of your head?
No.
Oh, okay, yeah.
Can I get it?
Yes, you can get a calculator. Like I said, you should bring one today. And you should have your own so you know where these buttons are. What was that?
Did you say that?
I did say that.
That was just
My bad.
All right, because the first thing we're going to do is we're actually going to find tangent values of specific degrees. Now, you have to type this in your calculator. Don't just go, yeah, I'll know how to do it later. I have to know if your calculator is in the right mode. Your calculator has to be in degree mode. If it's not, I have to kind of find where it is because every calculator is different, but we'll get there. All right, we're going to do the tangent of 74 degrees. Some of yours, you'll be able to hit your tangent button. It says a little TAN. You should be able to find it. Everyone's calculator will have that. If I push TAN right now, mine just blinks. For most of you, when you hit the TAN button, it'll actually say TAN in an open parenthesis, which is awesome. Mine, on the other hand, I actually have to hit the 74 first, and then I hit my tangent button second. But most of yours, you won't have to do that. That is just people using mine. You should come up with a decimal, and it should be about 3.49. If yours did not spit that number out, I need to know right now because it means yours is in the wrong mode, and I have to put it in the right mode. Yeah.
I'm just wondering, it's not in degrees, right?
It needs to be in degrees.
I mean, like, the answer.
The answer will not be in degrees.
Is it the line?
Yes, because it's a length.
Okay.
This is an angle, so I plug in an angle and I get lengths out somehow.
Degree mode.
Okay.
No, but what is the answer?
Yeah, because -5 isn't correct, right? So in yours, we're going to go to mode. And we're going to switch it to degrees. I'm going to hit enter, and now you're good for the rest of this class. You won't have to change that back until pre-calculus. Yours said, yep, just go to that degree. Hit enter. There you go. Now you're in the proper mode of this class.
I know.
You need to be in degree mode. Yep, like that. Now you should be in the right mode. Got clear a second. So we're going to go to our mode, and we'll see how it says radian. You're going to go over to degree. You're going to hit enter down at the bottom, and now you're going to hit second quit or clear to get out of there. Now you should be in the right mode. Yeah. Yours is in degree mode.
Okay. So
Oh wait, type it in. Yours is in a weird mode actually. Okay, you're good.
Okay.
Yep.
Oh wow.
Go to your mode, and you're going to scroll down. You're going to put it in degree, so you're going to slide over, hit enter, and now hit clear to get out of there. And now you're in the right mode. Does anyone else need help with their calculator? If you're in the wrong mode, you're going to get every problem on the test wrong. Not everyone, but a big majority of them. So you need to know how you calculate, all right? That's important. All right, type in tangent of 20 degrees however you see fit on your particular calculator. You should get out a number. And that number should be about 0.36.
Do you want to start into the 100s place?
I just did for this example, usually it's just the 10th or the nearest degree. If you look at your homework, it says to the nearest degree. So this one would have been 3 degrees and, well, 0 degrees if I was to the nearest degree. Are we all okay with that?
Are we allowed to write 0 degrees?
If I say round to the nearest degree, that would be 0 degrees, yep. Usually if it's decimals, I'd say to the nearest 10th or nearest 100th. All right, let's figure out how to use our calculator to find a missing side. So it says we're supposed to find side X, and it says use the 50-degree angle first. When you know an angle and you have missing sides, first of all, I'm going to say, is it a 60, 30, 90? Nope, can't use that. All right, do I know two sides I can use the Pythagorean theorem? Can't use that. So that means I have to use an angle and one side, which means I'm going to use tangent. So using 50 degrees is going to look like that. The tangent of an angle, in this case it's 50 degrees, is going to equal opposite. The opposite of 50 degrees is that x over adjacent, which is 27. And just like Emma brought up, there shouldn't be a degree symbol over here. These are the lengths of sides. That's why 3.49 is not a degree, it's that. All right. So we have tangent of 50 degrees equals x over 27. How do I get x by itself? Yeah. Yep, multiply by the reciprocal. In that case, we'd have 27 over 1, or just multiplying by 27, correct? So we're going to multiply the left and right side by 27 over 1. Other side by 27 over 1. I'm just going to leave it as 27. 27 over 1 and 27 cancel out. Or they turn to 1. They don't really cancel out, but they turn to 1. And we are left with x equals 27 times the tangent of 50 degrees. Now, we don't know the tangent of 50 degrees, so that means you have to plug it in your calculator. So you're going to type in 27 times the tangent of 50 degrees. Be careful here. Be careful here, and I'm going to put a little note down here. You can either write it or not. If you flip the order, you can flip it, so you can write it as tangent of 50 degrees times 27, but if you put it in like that, you're going to get the wrong answer. You need to close your parenthesis around any degree symbol if you're doing anything after it. Yes?
Do you want us to round before we multiply by the 27?
Do it all in at once.
Okay.
Yeah, you'll get a much more accurate answer,
Okay.
generally speaking. It's just for future reference, because when you get to pre-calc, you have a whole bunch of this in your calculator, and if you round at every single stage, you're going to be like 2 off. So in this case, just get in the hang of typing it all in your calculator. That's why I always put the 27 out front, because then you don't accidentally put it in the parentheses. All right, you should come out, I think around to the nearest tenth. I came up with 32.2. And it's not degrees, it is a length. So x is 32.2 units long. Using a 40-degree angle, we should come up with the exact same answer, but I want to walk all the way through this example so you can kind of see it in your head. So this one says use the 40-degree angle in this case. So that means we need to have tangent of 40 degrees is going to equal opposite. The opposite of 40 degrees is our 27 over x. To get x by itself, I cannot multiply by 1 over 27. That will give me 1 over x. Instead, the first thing I'm going to do is I'm going to multiply by x on both sides. So I'm going to multiply the right side by basically x over 1, so that my x's can cancel out. I'll just have 27 on this side, and we'll multiply by x on this side. And there's a specific reason why I'm going through this one, because of operations with tangent. First of all, this isn't tangent times 40. So you can't divide both sides by 40. You can't. It is tangent of 40. Tangent of 40 is a number. It's a number we just haven't plugged in our calculator yet, and we don't know offhand. So this is x times a number. You can divide both sides by a number. So that's exactly what we're going to do. We're going to divide both sides by tangent of 40 degrees. Since it's just a number, it's just going to turn to 1. Well, if I divide one thing on one side, I have to do it on the other side. So I'm going to divide the other side by tangent of 40 degrees. And we are going to have x equals 27 over tangent of 40 degrees. Type that in your calculator and make sure you get the same answer I do. In fact, we already know what the answer should be. It better be the exact same 32.2. Because that length can't change depending on what angle I'm using. It should be the exact same answer. Yeah.
So does that mean, like, if you mess up, like, which place the 27 of the x goes, you'll get the same answer?
No. because if you look at, this was the tangent of 50 in your calculator.
Oh.
This was the tangent of 40. Yep. If you switch where it's going to go, if you mess it up, you actually find, you'll end up finding this length again. You'll find the wrong length. Yep, so make sure you know which one you're doing and write it out properly. Otherwise, you're not finding the same answer. That'd be nice if it was, though, wouldn't it? Here's a big thing about this tangent of 40 equals 27 over x. What happens to the tangent of 40 and x? They just switch places, right? Yeah. It's a good thing to know. This pops up a lot where you have something equaling to something over that variable. You can either think your way through it, write it all out, or just realize that they actually just switch places. All right, let us continue. So that was tangent and how to use tangent to find a missing side. The next thing we're going to talk about is the inverse of tangent. So what tangent was basically I input an angle and it pops out the sides. It comes out with opposite over adjacent. That's what this first thing says. The tangent function tan takes an angle, theta, that is theta, but it really is just an angle, like angle A, angle B, and gives the ratio opposite over adjacent. So what that's saying is basically if you have tangent of an angle, let's call it angle A, is going to equal opposite side over adjacent side. Well, what does an inverse do? An inverse undoes what happened to it, basically. So if I have 3 times x, if I want to get x by itself, I divide by 3 because multiplication and division are inverses. They undo what each other does. 3 multiplies, and a division divides it back out. We're left with 1x. Same thing here. Our inverse undoes what the tangent function does. So a tangent takes an angle and pops out your sides. What an inverse does is it takes your sides and gives you back your angle. So that's why it says the inverse tangent function tan inverse takes the ratio opposite over adjacent and pops out an angle. So that's going to look something like this. From the example above, we would have tan inverse of the 2 sides, so opposite over adjacent. And when you plug that in, you're going to come out with an angle. So when using tangent, you should be inserting a degree. So tangent of 30 degrees equals some number. In this case, I'm going to insert some number, and it's going to pop out some degree. It'll pop back out our 30 degrees. Let's see an example of this. So here it says, you start with an angle, you run it through tangent, and you get your sides. You take those sides, and you plug it through the inverse, and you come back out with your angle. All right, a real quick example. See this 4.9, 2.8, and 4 triangle? It's got a 35-degree angle. So based upon the other side, we could say something like tangent of 35 degrees equals opposite 2.8 divided by 4.0. Everyone do me a favor real quick. In your calculator, type in 2.8 divided by 4. What do you come up with? About 0.7, right? Now type in tangent of 35 degrees. It won't be the exact, but it'll be pretty close. Comes about 0.7, right? So do we agree both sides are equal? Obviously, it's going to be a little bit off when you get decimals, because realistically, that side is probably like 2.79999, but it get rounded up to that. So those sides are equal to each other. Tan inverse undoes what tangent does to the left-hand side. So what you are allowed to do is really this is what's happening, is I'm taking the tan inverse of both sides. So pay attention here. I'm taking the tan inverse of both sides. So that's tan inverse of tangent of 35 degrees is going to equal what you do to one side, you have to do the other side. So I'll do tan inverse of 2.8 divided by 4.0. just like if I have 3x and or divided by 3, I'm left with just x. Tan inverse of tangent undoes itself. So they cancel out and turn to just 1. So that tan inverse and tangent just turn to 1. And so we're left with 35 degrees equals tan inverse of opposite over adjacent. Now in your calculator, can we all find our tan inverse button? It should be the same button as our tangent, but it should have like a little blue symbol or something above it telling you that you have to hit like your second button on your graphing calculators. Or in mine, it's a blue tan inverse, so I have to hit the blue INV button and then hit our tan inverse. So let's all practice right now doing tan inverse of 2.8 divided by 4. You should come out to like almost 35 degrees. Let me know if you're struggling with calculators. So plug all these in and make sure that you can do it. We all good? Did we get about 35 degrees on all our calculators?
Yeah.
I'll take that one yeah. Is everyone saying yeah? All right. So the real big thing you have to take away from this is that tangent of an angle gives you your sides. Tan inverse of your sides gives you back out your angle. That means we have kind of two ways to look at it. So it says find the measure of B and A to the nearest tenth. So if I'm looking at angle B, this is one way to do our inverses, is just look at our tangent. So we have tangent of angle B equals opposite, which would be 20 over 6. Then I could take the tan inverse of both sides to get the angle B by itself. So it'll be tan inverse of tangent of angle B is going to equal, take the tangent of tan inverse of both sides, so I have to take it of the right side too, tan inverse of 20 divided by 6. Since tan inverse and tangent cancel each other out, we're just left with angle B equals the tan inverse of 20 divided by 6. Can someone tell me what they get to about the nearest tenth? Yeah. 73.3. Yep. Angle B equals 73.3. And since tan inverse spits out an angle, I should put a degree symbol on it because we're talking about an angle. That's one way to do it, and it's kind of the way that is nice because we'll always remember what tangent equals opposite over adjacent. The other way we could do it, let's do it with angle A, is just to recognize if I'm looking for an angle. So if I'm looking for an angle, I'm just going to do the tan inverse of opposite over adjacent. So angle A would just equal tan inverse of opposite is 20. I'm sorry, we're doing angle A now, which would be 6 over 20. Either one of these methods are fine. I find more people tend to do this one later down the road because they kind of forget what inverse is and they actually have to do the full operation. But it's okay to recognize if I'm looking for an angle, I'm just doing tan inverse of the two sides. Can someone type in tan inverse of 6 divided by 20 and tell me what they get? Leisha. 16.7 degrees. Can anyone tell me if angle A is correct and B is correct? Is there a way to check to see if I got those both correct? Yeah.
You add them together along with 90, and if it equals 180, you got it right.
Yeah, we have 90 to spread out between A and B. So I just have to say, well, angle B plus angle A needs to equal 90 degrees. Is it okay if I cut out that 90 and just say those two have to equal 90? And then we just check it. We go 73.3 plus 16.7 does equal 90 degrees. So we are good. Labib.
On test, do we have to write this whole formula down, or can we just like write angle B equals tan negative 1 times 1 this?
Not times.
Or oh yeah.
Notice I'm specifically saying of. There is no multiplication here, but you are correct. We can say it's tan, so we can jump straight to this. So we can just say angle A equals tan inverse of 6 divided by 20. I am very specific to say of and not multiplication, because down the road people start dividing these. It's not a multiplication, it's an of. They are attached to each other. They are stuck together. The only way to undo it is an inverse. All right, otherwise they're always stuck together. So yes, you are correct. We could just jump here. That's why I said this is probably the easier way if you just memorize it. My left-hand way is just, I forgot what inverses do. Oh, yeah. It's just that. All right, let's go ahead and finish these examples really quick. It says find the missing variables. So they give me 55 degrees. What would this measure be? What would this angle be? Yeah, EJ.
35.
It'd be 35. So we could also use 35. But I'm going to go ahead and use that 55. So I'm going to say, well, we're given an angle. So I could say the tangent of that angle equals the opposite, which is 38, over adjacent, which is B. But you could have used that 35 too. If you use that 35 degrees, it'd be tangent of 35 equals B over 38. All right, in this case, I need to multiply both sides by B. That would get me B times tangent of 55 degrees equals 38. And then we are allowed to divide both sides by tangent of 55. But the tangent of 55 degrees must stay together. So that's going to give me B equals 38 divided by tangent of 55 degrees. And when you plug this in your calculator, you'll get out about 26.6. Would I put a degree symbol on it? Why or why not? Because it's a side. Yep. So we'll leave it as 26.6. How do I know if I'm looking for an angle? Krupa. The variable will be an angle. The other thing I'm looking for is if I'm using tan inverse, that comes out with the degree symbol. If I'm using tangent, there won't be a degree symbol. All right, our next one. We are given angle of 32 degrees, so we'll do tangent of 32 degrees equals opposite, which is R, over adjacent, which is 83. All right, so we just multiply both sides by 83. So we'll have 83 times tangent of 32 degrees is going to equal my R. Can someone give me what my length R is to the nearest tenth? Labib. 51.9. Perfect. And once again, we wouldn't use a degree because it is a length. I'm also using tangent, so that always results in a length. All right, our last one is looking for an angle. So should I use tangent or tan inverse when I'm looking for an angle? Tan inverse, right? So one way we could do this is, okay, an angle equals the tan inverse of opposite, I don't know what the opposite is. I know what the adjacent is, so it's something over 11. How do I get that? Yeah, Alicia. Well, we can always do a squared plus b squared equals c squared. If I know two sides of a right triangle, I know that third side, doing a squared plus b squared equals c squared. I'm not going to do the full, I'm going to kind of jump around with it. But you're going to start off with 11 squared plus, let's call it y squared, equals 16 squared. You would do some math yoga, I call it, and you end up with y equals the square root of 156, which you can reduce down to 3 square root of 15. I'm not going to spend a whole bunch of time on that because we just had a test on that. So that side is 3 square root of 15. I think the more interesting thing is the tangent. I think you guys can all do that. And here's why I think it's interesting. You have to type this in correctly. So I'm going to put a little note here. A lot of us are going to type it in wrong. You're going to hit your tan inverse button. When you type in your tan inverse button, yes or no, does it put a parenthesis after it? Yes. Okay. Then we'll type in 3. You don't have to hit a multiplication sign. We can just type in the square root button. Yes or no, your square root button has a parenthesis open symbol after it. Some of yours do, the graphic calculators will not. It'll just put it underneath. But for you using this, it'll have an open parenthesis. That means after I type 15 in, you have to close that parenthesis. You have to say, I'm taking the square root of just 15. So open a parenthesis, you have to close it. Then you're going to hit your division button, and 11, and you're going to close the entire thing off. If you type this in correctly, you should get out x is about, and since I'm using the inverse button, it should be a degree, so I'll have 46.6 degrees. That is the end of the lesson. What I want you to do is, if you did not get out 46.6, I want you to raise your hand so we can figure out how to type it in your calculator correctly. You don't want to get stuff wrong on the test just because you don't know how to push a button on your calculator. It'd be kind of, wouldn't that suck if you got your test back and all your things are wrong because you didn't plug in your calculator right? Yeah. So let me know now if you didn't get that 46.6. That's probably the hardest thing to plug in your calculator right now. Yeah. You do not. So for yours, you could just put the square root of 15. But for people that have these, when I hit like a square root button on some of them, it'll open a parenthesis, and if you forget to close it, it won't. No. But yours is a lot easier to use. All right, guys, the rest of the time.